Hi students, welcome to the session on plane wave propagation in free space. What is free space? Free space is one which has these three characteristics where conductivity is 0, epsilon is equal to epsilon naught and mu is equal to mu naught. Right? So by using this parameter we will find what is attenuation constant in free space, phase constant in free space and the intrinsic impedance and velocity of propagation. Right, so before you study this you must know how we have derived. Please refer my video on plane wave propagation in lossy dielectric. That will enlighten the reason behind this expressions. Okay, now we study what is attenuation constant when plane wave is propagating through free space. See, what is attenuation constant? When you substitute sigma 0 here, what will happen? This will be 0, 1 minus 1 will be 0, so 0 0 0. So alpha is 0. So what is the meaning? When wave propagates through a free space, there won't be any attenuation. No attenuation during wave propagation in free space. That is beauty, right? Next, what is beta value? Beta value is given by, you see, when you substitute again 0, this will be 0. 1 plus 1, 2, 2 by 2 cancel. So omega in plane mu epsilon, where mu is equal to mu naught, epsilon is equal to epsilon naught. So beta is equal to mu naught epsilon naught. Okay. So mu naught epsilon naught is nothing but our 1 by velocity. That is very important, right? So because v is equal to 1 by root mu naught epsilon naught. Hope you have studied this. Okay. Now we know what is velocity. That's what velocity of the freeze. Okay. You see, this is very, very important. So velocity of a plane wave when it is propagating through a free space is 1 by mu naught epsilon naught. 1 by mu naught epsilon naught. Mu naught value is epsilon naught is 8.854 into 10 power minus 12. Mu naught is 4 pi into 10 power minus 7. If you substitute, it will be approximately giving 3 into 10 power 8 meter per second. That's why, so what we are understanding, plane wave travels or propagates with speed of light in free space. This is the most important thing we must know. In free space, there is no attenuation. In free space, plane wave is traveling with the speed of light. So we got it. Lambda is equal to wavelength of the wave is 2 pi by beta. Right, so that is very, very important point to be noted. What is eta value? That is intrinsic impedance when wave is traveling through a free space. Again, you see sigma 0, mu is mu naught, epsilon is epsilon naught. So j omega cancel. So intrinsic impedance is given by mu naught by epsilon naught. Mu naught is 4 pi into 10 power minus 7. It is 8.854 into 10 power minus 12. If you simplify this, you will get impedance of 377 ohm. This is called intrinsic impedance. So when wave propagates through a free space, it will face the resistance of 377 ohm, that is equal to 120 pi. Fine, so it has resistance. Okay, this is known as intrinsic impedance or wave impedance. The impedance encountered by a wave when it is traveling through a free space is known as wave impedance, that is given by 377 ohm. Okay, already we derived a E equation. E is given by E naught E naught into e power minus alpha z cos omega t minus beta z ax. Here alpha 0, just now only we saw, so E will be E naught cos omega t minus beta z ax. How this equation has come, please refer my video on plane wave propagation in dielectrics. Similarly, I can prove that H is equal to H naught cos omega t minus bz ay. and wave is assumed to be propagating in z direction. So wave is in z direction, electric field is in x direction, magnetic field is in y direction, wave is in z direction. So you see, from this we understand both E and H are perpendicular to the direction of wave propagation, because E is in x direction, H is in y direction, which is perpendicular to z direction where wave is propagating, right? So this implies what you call, this indicates the fields lie in a plane. Fields lie in a plane that is transverse or orthogonal to the direction of wave propagation. Yes, because fields lie perpendicular. Orthogonal is nothing but perpendicular or transverse. So perpendicular to the plane. That's why such a wave is called transverse electromagnetic wave. Transverse electromagnetic wave. That is nothing but TEM wave. Fine. So this is very, very important, right? Next thing we have to remember from this is a combination of E and H is called uniform plane wave, right? So why it is called uniform plane wave? Because it has the same magnitude. It has same magnitude throughout the transverse plane. Throughout the transverse plane. That is another important point. What is transverse plane? Right? The plane where z is constant. Why? Transverse plane is nothing but x and y plane, because this E is in x direction, H is in y direction. So here only it is constant, means that is z is equal to constant plane, right? So that is another important point to be noted, right? So that's what their magnitude is constant all through the plane. You see the wave equation, E is equal to this one, H is equal to this one, right? So you see everywhere the omega is constant, frequency, wavelength, everything is constant. So E and H value will be constant all through the x and y plane. So it's not depending on position, right? You see, it's not depending on position. Frequency of the wave is fixed, time, wavelength is phase constant with fixed 2 pi by lambda, z is a direction, and you see E naught is magnitude. So everything is fixed. So these two fellows are constant in xy plane. Xy plane is nothing but a plane where it is nothing but a z is equal to constant plane. Fine. So what happens here is I can draw the waveform like this. How? Right? So if let us see, this is my x direction, this is my y direction, sorry, this is my z direction, and this is my x direction, sorry, y direction, right? So in which direction my electric field will be there? My electric field will be in x. So this is x direction. So it will be like this, and fine. So they will go like this. They will go like this. Okay. Then it will be like this. Similarly, magnetic field will be in y direction. So let us see. Okay. Right. So this is electric field direction. Fine. Okay. So magnetic field will be in this direction. Magnetic field will be in y direction. So that I can write as I draw in a different color. So it will be like this, y, fine, and it is coming like this. Fine, okay. So here you see this is my E is equal to E naught cos omega t minus beta z, or minus beta z, ax direction. Similarly, h naught cos omega t 0, I consider omega t is equal to 0, so minus beta z, ay direction. So the wave will be in z direction. Wave propagates through z direction. Clear? So that is very important point. The direction in which electric field points is known as polarization. So what is the direction of electric field in our equation? X. So it is polarized in x direction, right? So the wave is polarized in x direction. So what is polarization? The direction in which electric field points. That is what polarization means. So the direction in which electric field points is called polarization. In our problem, the waveform is polarized in x direction because ax vector, right? So I hope you understand everything clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.